Hello everyone. In this video, let us study about the need for modulation. So, in the first two lectures, I talked about the modulation. Okay, that is, I had given a demonstration on modulation technique. So here, what is the need for modulation? So you will be having a signal, right? So normally, if you have speed signals like 20 hertz to 20 kilohertz signal, why can't you send it? Okay, directly without any modulation. The thing is, it cannot travel longer distances. Okay, to make it travel longer distances, we have to go for modulation techniques. So what is the need for modulation? So let us take one by one and let us study. Okay, so first thing, it reduces the height of antenna. So why it reduces the height of antenna and how it reduces the height of antenna? Let us see that. Okay, so first we know 20 hertz to 20 kilohertz, okay, or 0 to 20 kilohertz signals we will consider. So for that, if I consider 10 kilohertz signal, okay, if the frequency of this 10 kilohertz, it's a signal is 10 kilohertz, then what is the wavelength of that particular signal? You know that the lambda is equal to c divided by frequency, c divided by f. So what is c? That is the velocity of light, and we can consider that as c into 10 to the power of 8. Divided by what is f? It is 10 kilohertz, that means it is 10 to the power 4. So this one will be 3 into 10 to the power 4, that means it is 30 kilometer, right? It is 30 kilometer. So the minimum height of antenna, okay, we will be considering it as lambda by 4, lambda by 4. So 30 by 4, okay, 30 by 4 if you consider, you will be getting around 7.5 kilometer. Right, 7.5 kilometer. If this is the required height for the antenna, then just think how large or how huge that antenna should be, and just imagine 7.5 kilometer antenna. So that is impractical, right? It is impractical, means it's not possible to have an antenna of size 7.5 kilometers. So that's why we go for this modulation. Okay, in modulation, what happens is we will be superimposing this lower frequency signal on the higher frequency signal. The message signal, okay, that will be the low frequency signal. Okay, high frequency signal is nothing but it is a carrier. Okay, sinusoidal signal will be considered, and I have covered this in the previous videos. If you have not watched it, then please go and watch those. Okay, so you will be having the higher frequency signal, you will be having the lower frequency signal. When this is superimposed on the higher frequency signal, they will be shifting in the frequency spectrum. So actually, before studying communication, you should be knowing about the signals and systems, that is Fourier transform. Okay, so suppose this is my frequency spectrum. Okay, this is my baseband signals. Okay, this is m of f, and this is my frequency. This is the frequency spectrum. So I'm giving the x-axis as frequency. So suppose this is FM and this is minus FM. Okay, this is the Fourier transform of m of t. Okay, this is a Fourier transform. So this is the frequency spectrum of the signal. Since this is centered around 0, this is centered around 0, this is called as the baseband signal. Okay, baseband signal. What is band pass? Band pass is a signal which is centered at some frequency other than the origin. Okay, suppose if I have FC, okay, this is FC. Here it will be centered like this. Okay, here it will be centered like this. So this is your band pass signal. Okay, so this is the baseband signal. So what happens is, when I'm superimposing the message signal on the high frequency signal, they will be shifting in the frequency spectrum. Okay, so the resultant will be this one. Okay, this one will be the resultant. So here what happened, from 0 it went to FC. So there is a shifting in the frequency spectrum. Okay, so that is your modulation. So now the high frequency signal means, shall I consider it as 1 megahertz? Okay, 1 megahertz signal I am going to consider. So if I am going to consider 1 megahertz, what is the lambda of this? It is c by f. 3 into 10 to the power of 8 divided by 10 to the power 6. So this is 300 meter. Okay, what is the minimum height of the antenna? Lambda by 4. So this is 300 by 4. Okay, so this one I can write it as 75, right? 75 meters. So can you imagine an antenna with the height 75 meters? Yes. So this is practical. So this is practical. So 1 megahertz, if I'm using this 1 megahertz signal, I'm going to get the antenna height 75 meter. What was the previous one? It was 7.5 kilometer. So with the modulation, now what happened? The antenna height, it reduced. So this is the first point. It reduces the height of antenna. Next, it increases range of communication. So this one in the first lecture I have covered. Okay, with the example of the paper ball, I have told you what happens when modulation is taking place. Okay, so this low frequency signal is message signal. So message signal, it cannot travel longer distances. That's why what is superimposed on the high frequency signal, because of which what happens, the attenuation reduces. Attenuation reduces, so it can travel longer distances. Okay, so that it increases the range of communication. Next is it avoids mixing of signals. Normally all the signals will be from like 20 hertz to 20 kilohertz signals. Okay, so that means the frequency spectrum also will be around, means it will be like it will be superimposing. I will show you. Okay, so suppose this is like this. Next signal I'm going to get like this. Okay, next I'm going to get like this. So what happens when these all signals, okay, it will be mixing. So you may get something like this. Okay, so at the receiver side, it is very difficult to separate the signals. Okay, when these are sent directly over a channel. So that's why we are going to modulate the signals differently, like with different carrier. I'm using the carrier C1T for this, C2 for this, and I'm going to use C3 for this. Okay, suppose this is my 1 megahertz signal, this is my 2 megahertz signal, this is my 3 megahertz signal. Okay, so when I'm using the different carriers for different signals, they are communicated through a single channel, then what happens, there will be no mixing of signals. Each signal will be occupying different slots. Okay, for example, this is my 10 kilohertz, this is my 20 kilohertz, and this is my 5 kilohertz. Okay, so what happens to this? You are going to get this first signal which is centered around 1 megahertz, and this one will be 1 megahertz plus 10 kilohertz. Okay, 10 kilohertz. This is 1 megahertz minus 10 kilohertz. So you are going to get something like this. And next one you are going to get 2 megahertz. 2 megahertz means somewhere here. You are going to get here. And the other signal you are going to get here, that is 3 megahertz, means somewhere around like this. Around 3 megahertz it will be placed. What happens? They are occupying different slots. So there is no mixing of signals. Okay, but if you are sending it directly without modulation, there will be mixing of signals. Okay, so you understood this point also. Avoids mixing of signals. So this is the multiplexing of signals. So this is the same concept. Here what happens is, to transmit multiple signals over the same communication channel, we will be using the communication technique like frequency division multiplexing. So this is the same concept here. Okay, it will be occupying the different slots, and these signals are passing through the same communication channel. Okay, so this is frequency division multiplexing. Okay, so this is all about the need for modulation.